Good morning, my dear students. Welcome to science class. And our 12th chapter is about to over. We are moving towards the exercise part. Before that, a little bit is left there. Let us discuss that and let us move through the exercise part and finish our lesson. So let's start. Welcome you once again to science class. And it is regarding the electricity bill. Okay. A small, it is not a topic, a small box is there. In that, some people are thinking that um, electrons are consumed in an electric circuit. Okay. We know that what we studied, we know that they are constituting the flow of electric current. So, what is consumed? We are providing amount for the energy, okay, for the energy to move electrons from one place to another or inside the gadgets. Yes or no? We are paying for the energy, electrical energy, not the electrons. Yes. And after that, there are two questions. What determines the rate at which energy is delivered by a current? So the answer is, I'm going to write on the board. The rate of consumption of electrical energy in an electrical energy in an electrical appliances. Is called electric power. Hence, the rate at which electrical energy is delivered by a current is the power of appliances. The rate of consumption of electrical energy in an electrical appliance is called electric power. Hence, the rate at which electrical energy is delivered by a current is the power of appliances. Is it clear? So what is next question? An electric motor takes 5 ampere from a 220 volt line. Determine the power of the motor and the energy consumed in 2 hours. Okay, let us go through that question. So, how power? We know that power P is given by the expression P is equal to VI. P is equal to VI, where V is equal to voltage, I is equal to current. V is equal to voltage, which is equal to 220 volt, and I is equal to current, which is equal to 5 ampere, right? So power P is equal to V into I, which is equal to 220 into 5, 220 volt into 5 ampere, which is equal to 1100 watt. Unit of power is watt. So we got that. Then energy consumed by the motor. Energy consumed by the motor. Consumed by the motor. That is given by PT. We know that what is P and what is T. P we got P is equal to 1100 watt and T is equal to 2 hours, which is equal to 2 hours equal to 2 into 60 into 60 is equal to 7200 second. 7200 second. That is energy consumed is equal to PT is equal to 1100 watt into 7200 second. Is it right? That is 7.92 into 106 joule. The energy consumed is 7.92 into 106 joules. Therefore, the power of the motor is 1000. This is the power of the motor. The energy consumed by the motor, (7.92) into 106 joule. Got it? So we are entering to our exercise part. Okay, let us do or deal with the exercise part. Exercise part, which is first one. A piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equal resistance of this combination is R dash, then the ratio R by R dash is what? That we are having 4 options: A 1 by 25, B 1 by 5, C 5, and D 25. Let us see. It is cut into 5 equal parts. And resistance of each part is R by 5. Done. It is connected in parallel. In parallel. So what? Equivalent resistance, how we can calculate? That is 1 by R is equal to first one 5 by R plus 5 by R plus 5 by R plus 5 by R plus 5 by R. It will be given by 5, that is 25 by R. We will get it as 25 by R. It's equal to 25 by R. Then R by R dash is equal to 25. Then the option D is the correct answer, which is R by R dash is equal to 25. Then second one, which of the following does not represent electrical power in a circuit? I square R, IR square, VI, V square R. Which is that? Which of the following does not represent electrical power in a circuit? Which is that? We have to check which are the things giving electrical power in a circuit. Okay, we have got 4 options, that is A, I square R, IR square, VI, V square R. Then for that, we know that electrical power is given by P is equal to VI. So one is C is over. C is related to power. Then according to Ohm's law, that one we are taking as equation number 1, and according to Ohm's law, what happened? Equal to IR. Then substituting in 1, P is equal to I square R. Is it right? I square R. So the option I square R, that A also related to power. Then from Ohm's law, we are having, and A and C is related, and which are there? The other things are B and D are there. Then from Ohm's law we are having I is equal to V by R. And substituting in one, we will get V into V by R, that is V square by R. That is the Dth. So which is left there? The question is what? Which of the following does not represent electrical power in a circuit? Then the answer is IR square. IR square. Okay, that is our B option. Okay, B option. So, what is the next question? An electric bulb is rated 220 volts and 100 watt. What is when it is operated on 110 watt, the power consumed will be? Option A 100 watt, B 70 watt, A 100 watt, B 75 watt, C 50 watt and 25 watt. And how will be the energy consumed will be given? Energy consumed will be expressed by P is equal to VI, which is equal to V square R. Then we can calculate the resistance. The resistance can be calculated by R is equal to V square by P. What is V square? $220 all square and P is 100. We have given the values and we got 484 ohm as the resistance. We got the resistance 484 ohm as resistance. And if the supply voltage reduced, the resistance will be same. The resistance will be same. Okay, if the supply voltage reduce, the resistance remains same, then power consumed can be calculated. Power consumed can be calculated as the same V square R. Substituting the value, we will get all square by R. For 84 ohm. Then we will get 25 watt. 25 watt. Okay. The power consumed when the bulb operate at 110 volt is 25 watt. So the answer is D. That is 25 watt. Let us go for one more. Two conducting wire of the same material of equal length and equal diameter are first connected in series and then connected in parallel in a circuit across the same potential difference. The ratio of heat produced in the series and parallel combination would be A 1:2, B 2:1, C 1:4 and D 4:1. Then let RS and RP the equivalent resistance in series and parallel. Okay, let RS and RP be the resistance in equivalent in series and parallel. And parallel. So we will get the ratio as 1:4. Okay, we get the ratio as 1:4, and the calculation for that, the more account for that, I'll give in the next class. And thanking you. I have to go through that little more. So I'll give the explanation for that in our next class. The answer is 1:4. Once again, I'll go through that question. Thank you so much. This is all for the day. Study well.